section where we want to start having archives of some of the things. Ready? Alright, so good morning class.
Good morning, sir.
Alright, so today we're going to be revising circle theorem, and so we have this diagram given to us, and the information here says the diagram not drawn to scale shows a circle with center O. So O is the center, HJ and GH are tangents to the circle. They touch the circle at one place on the outside. And angle JHG equals 48 degrees. We are now tasked to calculate, giving reasons for each step of our answer, the measure of, and the first one we want to find is angle that goes from O to J to H. So we're going from O to J to H. So the angle is right here. Now, how do we find the measure of angle OJH? What's the measure of angle OJH? Look at the location. It's right here. Where is it between? Where is this angle formed between? It is formed between a radius and a... And when an angle is formed between a radius and a tangent, what is that angle equal to? Angle formed between a radius and a tangent is equal to?
Right angle, 90.
Right angle, which is 90. So this angle here is 90 degrees, and our reason is angle formed between radius and tangent. So please remember that whenever an angle is formed between a radius and a tangent, it measures 90 degrees. And we can see that OJ is from the center O to the circumference, so therefore that represents a radius. As well as OG is also another radius. Let's go to the next part. Angle JOG. Now the angle that goes from J to O to G, which is right here. How do we find this angle? Not a cyclic, because this piece doesn't touch the circumference. So for it to be a cyclic quadrilateral, O would have to be at the circumference. But it's not a cyclic quadrilateral, but can we see a quadrilateral there? Isn't there a quadrilateral between the two radii and the two tangents?
Yes.
What did we say about the relationship between two radii that meets two tangents? The opposite angles are supplementary, which means then that angle JOG is equal to 180 minus 48, which will give me 132 degrees, and I can write opposite angles are supplementary when two radii meet two tangents at a point. So we could have found then this angle. And we need to read over this theorem, because the only way we can apply the theorem is if we know them. If we don't know the theorem, we are unable to apply it. So please spend time knowing the theorem. We're now at part 3 of the question. It says angle that goes from J to K to H. Let's just fill in right here at the center, which is 132. We're now going from J to K to G, which is right here. What's the size of that angle? What's the size of this angle? Where is that angle located? At the circumference. Is there a relationship between angles at the circumference? Or an angle at the circumference?
It is.
It is what? half of
Center.
what? At the angle at the
Center.
So please remember that the angle at the circumference is half the angle at the center, standing at the same point. You realize that both angles, they have J and G in common. Can you see that? So when they have both the beginning and the end points in common, they have a relationship. And this one is now at the circumference, this one is at the center, so the one at the center is twice the one at the circumference. So I can simply say this angle is equal to 132 divided by 2, and that will give us what? If we divide 132, we're going to end up by 2, we get 66 degrees, and we write angle at center is twice angle at circumference standing in the same segment. So I can fill this one in now as 66. Our final angle is now angle that goes from J to L to G. So the angle that goes from J to L to G, which is right here. How do we now find that angle? It's at the circumference, but is it standing in the same point? No. So we have to be careful now at this angle we're saying at the circumference. Look closely at the shape within the circle. What do we notice about the shape within the circle? What kind of shape are we seeing within the circle? Which has 4 sides. So therefore it is a cyclic quadrilateral. And what do we know about opposite angles in a cyclic quadrilateral? They are supplementary. So we know that K and L must add up to 180. So then this is going to be 180 minus 66. Can we see that?
Yes, sir.
Which is going to end up giving me 140 degrees. And we say opposite angles in a cyclic quadrilateral are supplementary. Alright, so we will have been at the end of that question.